Hi guys, so what are we going to learn in this module? We are going to learn what exactly is an IP address, a dotted decimal format in which it is represented, what are subnet masks, IP address classes, network and broadcast address, configuring an interface which we will demonstrate in this video, then what are private IP addresses, the IPv6 which is the successor of IPv4 and network address translation. Let's see what all this means. So what exactly is an IP address? It's the protocol for routing packets across the network. If I have to send a packet from A to B and I have to know the address of B, in a similar fashion, if I have to send a data packet from node A to node B, I need to know the IP address of node B. An IP address may be defined as a way to identify a host on a network. IPv4 is a 32-bit binary number. As shown, this 11000 and so on, it is an IP address. Now, it is difficult for us humans to communicate in this way, so we have another format known as a dotted decimal format. An important thing to be noted here is since it is a 32-bit binary number, there are 2 raised to the 32 possibilities of IP addresses, but not all are used, are they? So, the dotted decimal format. IP is divided into 4-bit octets that the 32 bits are divided into 4-bit octets, each comprising of 8 bits. So 11000 and this IP address translates to 192.168.1.1. It's convenient, isn't it? One thing to be noted here is that all the numbers in the IP address can never be zeros because that's the address of the source which is sending the data packets and can never be all ones because that's the broadcast address. In a broadcast address, if you send a data packet to this address, it is sent to all the computers in the network. The local loopback address is 127.0.0.1. It's the local loopback address of your own computer. Each IP is made up of two pieces, the network portion and the host portion. The network portion gives the address of the network, while the host portion gives the address of the specific node in the network. So it is also a 32-bit number and tells the gateway which of the bits in the address are of the network portion and which are of the host portion. It is represented in the same dotted decimal format 255.255.255.0. So let's see how it actually works. If my IP address is 192.168.1.1 and my mask is 255.255.255.0 and we convert both of them in the binary format, on doing a logical AND operation on these two individually bitwise, we get an address which is the network address. After doing so, we will get back 192.168.1 which is the network address and the remaining portion that corresponds to all zeros is the host address. Here again it can be seen that 131.108.2.2 is translated into its binary format and so is its net mask and a logical AND operation is done. When we get to know that the network address, we choose from E0, E1 and E2 and select E2 which corresponds to network address. Then we use the host part of this IP address to communicate to node number 2 to which our data packet is successfully sent. IP address can be divided into certain classes. In class A, the first octet comprises of numbers from 1 to 127 and has one octet for the network part and the rest 3 for identifying the hosts. So in this case, since we have 8 bits identifying the network, we have 2 raised to the 8 maximum networks, while there are rest 24 bits for the host. So in every network, there can be 2 raised to the 24 hosts. In a similar fashion, class P has the first 2 octets reserved for networks. In this fashion, 2 raised to the 16 networks can be connected and each network can have 2 raised to the 16 hosts. C is also done in a similar fashion. D and E are a bit special. These IP addresses have the numbers 224 to 239 and are used as a multicast, while in E it is 240 to 255, which is used for experimental purposes. These two are beyond the scope of this lecture module. So why don't you pause your screen and answer these two questions to test your understanding of what you have learned till now. So, private networks. These networks are not directly connected to the internet. It may be a network at your home as well. They may have globally non-unique IP addresses. That is, the router in your own home may give an IP address to your computer, which may be uh, locally unique but not unique globally. That is, it may exist around the internet as well, but there's no worry since that part is out of the scope. So locally it's unique and does not cause much trouble. Generally, private networks use addresses from the following experimental range. These three ranges are given. So, how do we connect a private network to the internet? For this, we use a network address translation device which has its own public address and private address. So, public address is globally unique. We should note that. So, the computer here H5, if it wishes to send something to the computer H1, um, its source is obviously public address, but its destination is the public address of the NAT device. So, it sends the packets to the NAT device, which further distributes it among the network to the host H1 by using its private address. So, let us now see how to configure our own network on our computers. First, we may go to the control panel. In First, you may go to the control panel, then into the network and internet, then to the network and sharing center, where we can see our computer connected to the internet. Then we will go to change adapter settings. Now we can see the connections that our computer is connected to or was previously connected with. Now, this shows the bytes that have been sent and those that have been received. Now, if we want to change the IP address of our computer, we click on properties, then IPv4. Now, currently our computer is using a dynamic IP address, that is, it is obtaining an IP address automatically. What if we want to give our computer a static IP address? Now, for this, first we need to know some basic definitions. We know IP address, we know subnet mask. Default gateway is the address of the router. Then there is a preferred DNS server and an alternate DNS server. Now, where do we get these addresses? First, go to Start, then open command prompt in Windows and type ipconfig all. This gives a list of many addresses. Now, since I'm connected to a wireless network, I will find the wireless addresses. So, here is the set of the addresses I need. Let's open it on the side. Now, here is all I need. Now, we can change the IP address to static by entering the numbers. You will notice that a subnet mask appears automatically. Now the default gateway can also be set, which we obtained from CMD. Now the DNS server address is also present there. So now we have made our dynamic IP address into a static one. Let us try. See, Google is still working. Now let us try something new. How about typing IP address on Google? When we type IP address, we get something that Google gives us automatically, that is 192.162.185.34 for this specific computer as a public IP address. Now, by public IP address, Google means that this is the address by which this computer is recognized on a global scale. Uniquely, this address refers to my computer on the internet, as the IP address, etc., were given to me by the internet service provider. Now, let's learn a bit more. This is a part which I wanted to show you. Each public IP address is assigned to a range of block of addresses. The Internet Assigned Numbers Authority (IANA) controls ownership of these IP addresses and assigns each block to organizations such as the Internet Service Providers, that is, people who provide us internet, who in turn allocate individual IP addresses to the customers. So the public IP address we just saw was given to us on a global scale, while this individual IP address, which we see when we click on command prompt, it is given to us by our internet service provider. Now let us revert back the changes we made. By making it into a dynamic IP address, our computer gets an IP address automatically through a DHCP client, through DHCP. So now let's summarize. What did we learn? An IP address is the main protocol for routing packets across the network. It has two parts: host and network. The private networks are not directly connected to the internet and may not have global unique IP. For those who are wondering more, can easily Google this out. The NAT device also allows a private network to become connected to the internet or other networks. So now, just before I miss out, let's hear something about the IPv6. IPv6 is the IP version 6, which has been now defined and developed. Instead of the 32 bits which are currently used, it uses 128 bits to accommodate the growing number of computers in the internet world. IPv6 uses the hexadecimal numbers to represent these 128 bits. Since it's a new software, IT staff must be retrained to use it. It will most probably coexist with IPv4 for the years to come. So why don't you all pause your screen and answer this revision quiz at the end? There are a set of three questions.